Let's talk about the homework. See how we might have done. If you had questions, concerns, ideas. Yeah, go ahead. 14. 14. Number 14. Let g at x be the percent of your friends with a landline phone in X years after 2000. Explain the meaning of each statement. Okay. That's the one, right?
Yeah.
Thank you very much. Okay. All right, so they say that this is related to the landlines. That's the phone like these that are connected to the wall, right? So g at 0 equals 100. Okay? Well, g at 0 means the very first year, the year 2000. In the year 2000, because that's when this started, you will have 100 friends that will still have a landline. Okay? Is this real data? I don't know. It's just made up. And then what does g at 5 and g at 6 mean? That means that in 2005 and 2006, you will have the same number of friends with landlines. You're not solving it at that point. It's just, that's all you're doing is. So in 2005 or 2006, and the reason it's, because it starts in 2000, so 2000 is year 0, 2001 is year 1, 2002, so g at 5 is 2005, g at 6. So that just means that you would have the same number of friends that would have a landline during those years. It would be a constant amount. So would it be less than 100? I don't know. According to this, probably decreasing. So let's just pick a hypothetical number saying in 2005 you have 30 friends still with a landline, and then also in 2006 you have 30 friends with a landline is what that basically means. I don't know if it's 30, you're just picking up a hypothetical. And then they talk about g at 10, and I think this might be a misprint, is equal to m. So g at 10 would be, this would be, bless you, this would be the year 2010, and you have m. I think that might be a misprint. It doesn't make sense to me. Because when it was equal to a number, that's how many friends had a landline. But in 2010, you have m friends that have, that doesn't make sense. So that might be a misprint. I don't know why that is that way. And then g at 11 is greater than g at 12. So that means in 2011 versus 2012, more friends had landlines here. So what is the actual value? We don't know. But more friends have landlines there than they do in 2012. So in 2011, let's say you had 30 friends with landlines. In 2012, maybe you had 25 friends with landlines or something like that. So it's just, that's all it's saying. Other questions from the homework that you might have come across? Yeah? 18. All right, then you want to have h at x. H at x is equal to 6 minus 2/3 x. And then we want to find h at 3. Okay? That means I'm going to take that 3 and I'm going to plug it in right there. So it subs in. So h at 3 is equal to 6 minus 2 over 3 quantity. There was an x there. Now I'm going to put the 3 there. Okay? 2/3 times 3, well, you can just reduce it. That's 1, 1. So I get 6 minus 2 times 1, which is 6 minus 2, which is 4. Okay, so your answer is 4. The point that this talks about, the ordered pair, would be 3, 4. So this is the true answer we're looking for, but it does yield us a point 3, 4. What other questions did you come across on? Yeah.
Can we go to number
10?
10, please?
Yeah. Number 10. Let's find the domain of the function represented by the graph. Determine whether the domain is discrete or continuous. So I'm just going to put the ordered pairs. It looks like I have, I think that would be 4, 3 for one of the points. Another point would be 8, 9. And another point we would have 12, 16. 12, 15, excuse me. And just notice that we didn't count by ones. We gauged by 2. So find the domain of the function. So the domain of the function is just the x values. They use a fancy bracket that no one can ever draw, including me. That's the domain. Should you have it in any particular order? I guess the really smart people put it in ascending order like that we have it in, but you could have it all mixed up. And then determine whether the domain is discrete or continuous. It's discrete. These are just points. This is not a graph that goes on forever. Okay, they're just points. Discrete. What other questions did you come across on the homework? Number 11. Number 11. So if you look at number 11's graph, it does something like this. You have 2 points at either end. Okay. So what is the domain? The domain goes basically 0, 1, 2, 3, 4, 5, and 6. The reason you're including 0 and 6 is because you have a solid dot at each end. Okay, so I just looked at the x component of our graph. And then this is discrete because it starts and stops. You have endpoints. Discretes, yeah, no, I'm making up words now. Yeah. 19. I have the function at x is equal to 8x minus 7. I have the function at x is equal to 17. So you're talking about the exact same function because you have f and f. Okay? That means I'm going to take this and this and set them equal to each other. So add 7 to both sides and divide by 8. That would be your answer. Cool. Any other questions you'd like me to go over? Cool. Yeah. 12. Number 12, it says in exercise 12:13 to determine whether the domain is discrete or continuous. Okay, so 12, you have input months 1, 2, 3, output height of a basal plant 3, 7, and 11. I would say that's discrete because 1, you don't have an infinite amount of months, and 2, you're going to get to a, you're not going to get a basal plant that's as tall as the redwoods in California, right? Does that make sense? Same, yeah. Yeah. 17. Number 17, we have the function at x is equal to 1/3 x minus 1, and they want to know what the function at 0 would be. Okay, so that means I'm going to take 0 and plug it in here. So the function at 0 is equal to 1/3 times 0 minus 1. 1/3 times 0 is 0. So my answer should be just -1. We good? Yeah.
13 is
Yeah, it's got to be discrete because you only have so many tickets. Yeah, it's not infinite. All right, make sure your name is on that assignment and anything else that you might be handing in, please.
This is pretty much everything that's in my.
Thank you. Thank you. Thank you. Thank you. And thank you. All right. You got one more? Cool. Thank you. All right, so coming back out to y'all, we'll start on this side of the room, is old assignments. I think we have names on them all. Thank you. All right. Here we go. So, we have been talking about linear equations, yes? Okay, and that's something that forms a straight line when graphed. And things about straight lines that we should know. You have straight lines that have a positive slope. We have straight lines that have a negative slope. We have straight lines that are vertical, which have an undefined slope. And we have straight lines that are horizontal, which has a slope of 0. Okay? So we're going to learn how to start graphing linear functions in standard form. So before we get into the schematics of it, there's a few different ways that we can represent linear equations. Standard form is one of the forms that we're going to use. Standard form has the x and the y on the same side. Other forms that you might come across is something called point slope form, which means you have your y components on one side, your x components and slope on the other side. You also have slope intercept form, which means you've solved it for y, and you can identify the slope and the y-intercept pretty easily. What's the benefit of any of them or all of them? One, linear equations are a building block to all the rest of the graphing scenarios out there. So let's take a look. So we already know a lot about how to graph lines, but we're going to review some methods that you might have already learned. And if you don't know it, this is a fantastic method. So standard form, you have ax plus by equals c, where a, b, and c happen to be numbers. Okay? X and y stay as x and y. And the nice thing is if you have your graph in standard form, we can graph this pretty easy by using something called the cover method. And that allows you to find where it crosses the x-axis. And where it crosses the x-axis is a point. And where to cross the y-axis, which is also a point. Okay, and if it's a point, bless you, it's x comma y. Okay? This is a really simple way, and it's a quick way to graph linear equations. Where things that might not always be perfect is if your a and b values, which are numbers, if they go into c evenly, meaning you don't create fractions or decimals, it's a really good method. If it does create fractions or decimals, you're really having to approximate a lot more of where to graph your linear equation. Okay, you can know approximately what it'll look like, which is fine. The graphing calculator does not take it as standard form, knowing how to graph as far as the older ones. Some of the newer versions will indeed allow you to plug it into standard form, but it depends upon what series of calculator you have. And again, once you see this, you're going to be like, oh, that's pretty easy. So the x-intercept is right here. Agreed? So that is a point. That point right there is the point 6, 0. Meaning I would go 6 in the x direction, and I would not go up or down at all in the y direction. What does it appear that the y-intercept might be? Okay. What does it appear the y-intercept would be if you look at the 0, 3? Good. So right there, our y-intercept is 0, 3. Okay, so y-intercept, x-intercept's right there. Okay, it's where it crosses the x or the y axis. That's all it is. Does that seem okay so far? So when we use the cover method, we are focusing on where it crosses the x and the y-axis. So watch how easy this is. Just put your pencils down for a moment and take a look what we have. Ready? I'm going to cover up this y value. Still with me? So the 4y doesn't technically exist right now on this graph. So as far as if I cover up the y value, that means I have a 0 in place of the y. That's what all of that. So I'm covering up the y value. If I cover up the y value, that means that a 0 is the placeholder. So 2x equals 12. What do I have to do in order to get x by itself if 2x is equal to 12? Divide by 2. So x is equal to what? 6. Yeah. So 6 comma 0 is right here. This is where it crosses the x-axis. We don't know this is the x and this is the y. Okay? Now, if I'm going to cover up the x value, what value goes in for x? If I cover up the x value, what value goes in for x right here? I cover up the y value here. What value went in? 0. So what should I go in with the x value? 0. So now I'm going to just cover up my x value right here so I get positive 4y is equal to 12. So what should I do to both sides to get 4y equals 12? Y equals what? Divide each side by 4 so you get y equals 3. Lo and behold, you create your line.
Would it be an infinite line or defined?
Yep, infinite. It'll go forever and ever. So where's my arrow line? Looks like I don't have fun materials. All right, so goes right through them. Put an arrow on each end because it goes forever and ever. Hey, quick question. Does anybody know? Is this line increasing or decreasing? Hang on, before you shout it out, what do you think? It's decreasing. It has a negative slope. It's decreasing. Does that make sense? That's a property we talked about, right? So this is decreasing. It has a negative slope to it. So no matter where I pick 2 points on this line, if I found the slope, I would have a negative slope. That means this line is decreasing. Yeah.
If it goes right diagonally,
If
then
it
it
was going the other way, yep. Increasing, yep. All right, so cover method again. So let's figure out where it crosses the x-axis. So that means that I'm going to cover up y. So I'm plugging 0 in for y. So if I cover up this y, I get 5x equals 10. So what's x have to be equal to? 2. All right, now let's figure out where it's crossing the y-axis. So I plug 0 in for the y value to find where it crosses the x-axis. Where am I plugging 0 in now? The x-axis. All right, so if I plug 0 on the x-axis, I'm going to cover this up. So I get negative y equals 10. So what's y have to equal? Negative y equals 10. So what's y have to equal? Negative 10. Good. So that's down here. Yeah,
if it's just a variable itself.
we'll get there.
Okay.
We'll get there. That's what that line looks like. There's an arrow at both ends. It goes forever. In your thoughts, would this be increasing or decreasing? Yeah, please have your phone in your ID, please. I'm sorry, was this increasing or decreasing? Increasing. So if it's increasing, what can you tell me about the slope? It's positive. Okay, this is really good, rich language to know. Okay, so it's increasing, so it needs to go right to boom, positive slope. Decreasing, negative slope. That's it. All right. Am I missing a value here?
You can just put it right on the x-axis.
So x equals 4. This is a line. So let's think about this. X equals 4. That's over here. Agree? But it's not a point. It's a whole line. If it was a point, I would have 4 comma 0. Yes? Any idea what kind of line this will be? Don't say straight because we know it's straight. It is a vertical line. So x equals creates a vertical line. Is this increasing or decreasing? Trick question.
Neither. It's neither.
Neither. So this type of line, a vertical line, has an undefined slope.
So if it's a vertical,
Okay.
it's just a
Which means if
horizontal.
you used your slope equation, you would have 0 on the bottom, and there would be some number on top. Some number divided by 0 is undefined. So if the 0 is under, so in the denominator, if it's under, it's undefined. If the 0 is under, it's undefined. And I want you to make that goof up. That make sense? So this is a special case where you just have x equals a number. This is forever undefined. It becomes a limit in calculus. Now I have y equals -3. What do you think happens here?
-3.
It's going to be
What kind of line?
Horizontal.
A horizontal line, right?
If it's so on the x-axis, it's vertical, and
It's
then y,
still a
it's just horizontal.
Boom. Horizontal line. Negative to positive infinity is the domain. You're absolutely right. Hey, quick question. Is that a function?
no.
No. Vertical line test doesn't pass. Is this a function?
Yes.
Yeah. Let's see. Horizontal line. Your slope is equal to 0. So you would have 0 on top over a number. Just whatever number might have come out. Good. It won't be 0 over 0. It'll be like 0 over 7 or 0 over -6 or something like that. So y equals creates a horizontal line through that value. X equals creates a vertical line.
Would this be considered a positive line?
No, it's neither. This is a constant line. It doesn't have any rise to it, so it'd be holding true. So word problems that you might come across, like on SAT, ACT type of stuff, would be a graph like this, and if it said, this is how far Billy has run from his house, and it goes up and down like this, and then all of a sudden you have a horizontal like this, what does this mean? That means he's keeping a constant distance from his house.
Yes, sir.
Like he's
Not
running,
going anywhere.
he's like running as on a radius, like it's a circle. That would be, yeah. All right. Ooh, yeah. Dude, we're done? All right. So your assignment for tomorrow is page 57 and page 58. Page 57 and 58.
Let me start that right.
Heck yeah, you got time.
16 minutes.
Yeah, we got done early. So page 57 and 58. Start it now, please. Use this time wisely for you. Okay? Good job today, everybody. Man,